and he's presenting the view of Munich Re when it comes to quantum computing opportunities and risks. The stage is yours.
Okay, then I will just start. Good. So my name is Andreas Nawroth. I'm leading expert at Munich Re, and I want to tell you about the opportunities and risks that we see on quantum computing from the risk perspective. So let me start with a small introduction. So we have bits and qubits. For classical computing, it's quite easy. Basically, a bit is encoding just 0 and 1, while a qubit can represent both 0 and 1 at the same time. If we go to the performing of operations, a classical computer operates on single bits and is generating single bits, while a quantum computer can take a superposition of states and transform it to another superposition of states. What is now quite interesting is if you come to the scaling properties. So in a classical systems, each bit is encoding one binary parameter, while in a quantum system, each combination is assigned a coefficient, and the numbers of parameters that can be represented are growing exponentially. And that's what we are really interested in. So the number of complexity that we can basically tackle with a certain quantum computing system. So let's go to the extraction of information. So for classical bits, this is we can just read out the information without changing the system. But for qubits, this is different because in order to access the information, the existing state is destroyed and just one state is left. This is what we call the measurement process. And what is also important is the extraction of information. So the measurement has a random element to it. And this will become quite important. The second point with respect to the cyber aspect, and the third point with respect to uncertainty. If we now look at the algorithms. So an algorithm is just a string of operations performed to solve a problem. Quantum algorithms can take now advantage of a superposition of states, meaning that all possibilities are analyzed at the same time instead individually. And for us, this is quite important because as an insurer, we are dealing with many scenarios and we are just interested in a few of them. So finding them for us is quite crucial. And obviously, there are algorithms to help you to boost, for example, the amplitude of the relevant scenarios for you, so that if you do a measurement, you are really extracting the right scenarios. So to summarize, we think quantum computing can be extremely fast to simultaneous calculations. Entangled qubits can increase performance really exponentially, and therefore we are able to solve exponential problems like, for example, quantum chemistry or high-dimensional machine learning. But on the other side, these systems are still quite sensitive. They need currently quite extensive error correction. Results are often probabilistic instead of deterministic. And it's not really clear when we will achieve enough high-quality qubits or which technology is currently the most promising one for us. So to summarize it in a nutshell, we think with respect to technology, we are really here in a high-risk, high-reward scenario. So let me now come to a big question we have as an insurance company. So can quantum computing really help us to solve our problems, and how can we keep up? And let me expand a little bit around that. So we are living in a complex world with fast changing environment like climate change, or technology like quantum, and associated risks. And from our point of view, current technologies are not really able to cope, but quantum computing can help perhaps by delivering fast scaling computational power. The problem that we have is that historical experience is no longer as helpful as it had been before. And one example is if you take climate change is influencing droughts, hurricanes, or other events like wildfires. So basically the frequency of events and also the magnitude are changing quite fast. So history is not really representative of the future. On the other side, there are more and more technologies that are going productive before they are really fully understood. And to make that more concrete, I brought one example from the machine learning AI domain, and we will see later on how this relates to quantum computing. So a couple of years ago, we had some breakthroughs in machine learning, and we had models that allow us automatically to use unstructured data like text and images for many applications. But then a couple of years later, we detected really some unwanted side effects. So we had some biases in the systems that we didn't want, or we had some new attack vectors from a cyber perspective. And what we developed then now, 2-3 years ago, is a productive solution called AI Sure, that is ensuring these kind of algorithm-related problems. And to make it even more concrete, I brought here 4 public examples of companies that we are insuring. So for example, dynamic infrastructure, this company is dealing with infrastructures using images and algorithms and structured data to tell when we need to repair certain infrastructure. Sepio System is a company that is mitigating cyber attacks based on hardware or firmware. Frogster is developing algorithms that are preventing credit card fraud, and Spectrum Labs is trying to detect toxic content in certain online medias. These are completely 4 different fields, but what they have in common is that there is an algorithm at heart that is providing this kind of functionality. And what we try to do is providing an additional security layer around this algorithm that helps these companies to really sell their products to bigger customer. For the customers, we really are taking out the residual risk out of the calculation. So the business case is becoming much more easier. Either it's positive or negative, but you don't have anymore so many random components in it. So how can we transfer that back to quantum computing? We think that quantum computing, together with our unique know-how, can be an answer to our fast changing environment we are currently living in. And we think it will also enable our partners to do even more innovative business. And in the end, it will also transform the insurance industry as a whole. So we really see potential application in many domains, but to make it more concrete, I brought here 6 examples where I would like to show what is the potential impact on quantum computing and how it would impact the insurance industry. So the first is climate change. Here we think that quantum computing will really improve the climate and weather simulations that we can do. This will enable us as insurer to understand much better the risks associated with a certain location, like what is the probability of flooding for a specific building, for example. It will also enable the building of systems that create early warnings before extreme events in a much more accurate and granular way. For the insurance industry, this is a big deal because NatCat insurance is typically a bigger part of a risk portfolio of many insurance companies. The second domain that we are seeing is green tech. So here we think that quantum computing can really help us to optimize the design of renewable energies. So solar cells, wind turbines, and for example, energy storage through batteries. And what we are doing here now is we are providing performance guarantees so that the newest developed technologies can be deployed much quicker than otherwise possible. The third domain is pandemics. Here it's about how can we take a piece of genetic code and then reconstruct, for example, the structure of a virus, design medical substances that are that can counter this virus, or how we can model the spread of epidemics. And we think that quantum computing can really help in all 3 domains. We're providing pandemics cover that are quite heavily reliant on this kind of modeling, and that will provide help or cover against residual risk, at least from a financial perspective. The third domain is logistics. With respect to logistics, this is a classical case. It's all about route calculation and supply chain. For us as an insurance company, it's mostly about supply chain resilience. We have products out there like contingent business interruption that help to deal with these risks, but they are very difficult risks from an insurance perspective because very small changes can create big effects on the supply chain. And current technologies are not really able to model that. The fifth domain is cyber. So this is about how quantum technology can help us to build much more secure communication systems, but also secure existing IT systems. And it's one of the world's largest cyber insurer. We are really quite interested in any change of the risk landscape there. The last domain we call Rise of AI. This is about the broader application of machine learning algorithms. And here how quantum computing can really help. These algorithms over the hardware bottleneck, how quantum computing makes this algorithm more secure and more efficient. And I already told you a little bit about how we think we can ensure these kind of algorithms. Our mission in all these different domains is always the same. How can we faster and better understand, calculate, and ensure the residual risk in order to enable our partners for faster technology adoption? But in the end, it's all about resilience. How can we increase resilience for society, business, and individuals? So this is a quite big problem, and we can't do it on our own, obviously. So we are part of different groups. One of them is QTEC. It's an industry consortium consisting of 12 corporations, and we want to position it as really a driving force behind the industrialization of quantum computing. I think what is quite important is to take the excellent know-how that we have in academia and really transfer it to the economic side, and we hope to achieve that. And obviously, we try to stay as fast, as agile as possible, as also quantum technologies are changing very fast. But what are exactly the risks and the opportunities we see in quantum computing, and how can we master them together in a successful way? If we look at quantum computing and the associated risk space, we really see three dimensions that for us are quite important. So the first risk dimension is about the physical aspects. So for example, it's about stable and secure production. So certain physical properties constrain us for cloning of quantum information. This means that many backup strategies that we are now deploying for classical computers or IT systems will no longer be valuable. And that means that the potential impact of business interruption or cyber risks will become much more important and bigger. On the other side, there is quite some potential by building stable, secure, and efficient infrastructure and services to counter these adverse effects. Residual risks can be insured with traditional insurance products here. The second risk dimension is, I would say, a little bit more complex and abstract. Here it's about the algorithms. We think that quantum algorithms are quite new, under development, and from our perspective, not really well understood yet. Therefore, we think that many pitfalls and constraints of quantum computing will emerge during production time. Similar like it has happened for machine learning, as I told before. On the other side, we see a big potential because if we can pick the right algorithm and apply it, I think we will be able to generate solutions with an accuracy and a granularity that was not possible before. How to cover residual risks? Here, I think we can deploy similar strategies like we developed for AI Sure. And now coming to the third dimension, and this is perhaps the newest and most complex one and most abstract one. That's what we are calling the probabilistic worldview. Quantum computing will really help us to solve completely new classes of problems. But the problem is the answers will be quite often in a probabilistic form, not in a deterministic form. And we think that will have quite some profound implications. We think that in many industries, the business processes are not really adapted to deal with probabilistic solutions or probability-weighted information. On the other side, there is a tremendous potential, I think, if we we are able to solve new classes of problems, we will open up complete new business fields. And we think it will be similar, like, for example, the internet transformed commerce to e-commerce. With respect to residual risks, this is something where we already started a strategic development of assessing these kind of risks and trying to ensure them. But here we are open really for co-creations, co-development, because we think so much information from many different industries is necessary to make this really a viable product. So let me close. I think only together with really diverse partners, with really very diverse knowledge, we can realize these opportunities and potentials and really develop solutions for the upcoming problems of our times. So thank you very much for your attention. Are there any questions?
There are no questions in the chat, but I would just ask you one question. So can you describe a little bit in detail how the interaction with different German companies in QTEC concretely works when you discuss together with partners from German industry?
Yes, sure. I'm happy to answer that shortly, as we have tomorrow already like a separate talk specifically around QTEC. But basically what we are trying to do is discussing with the companies what are like the kind of problems that we see, determining what are the problems where we see a high potential, then developing a platform where we can code together to find solutions so that everybody can really learn from this experience. So the idea is that not every company is repeating the mistakes, but rather we do it together, we learn from the mistakes and then use the knowledge also to build our own products.
That sounds very interesting and very like an ecosystem joint effort approach. Very interesting. So we're very interesting too, as you said, in the panel tomorrow discussing this in detail. Thanks a lot, Mr. Nawroth, for this very interesting presentation.